Good afternoon, everyone. My name is Piehler, and today I'm going to be going over my 909 project, which was a habitat suitability analysis for the Texas horned lizard. For a bit of background, the Texas horned lizard is the state reptile of Texas. It's a small desert lizard that was once common throughout the American Southwest, from Arizona over to Louisiana and from Oklahoma to northern Mexico. And that's the majority of its native range from Arizona, New Mexico, Texas, Oklahoma, and Kansas. While it was once abundant, its population has been in pretty steady decline since the 1950s, partially because they were sold as souvenirs at truck stops throughout most of the state. Currently, they are protected by the state of Texas, though, so it is illegal to own one without a scientific permit. When they're fully grown, they can be anywhere between 2 and 5 inches long and weigh between 25 and 90 grams. Another unique characteristic of the Texas horned lizard is that they have developed the ability to shoot a stream of foul-smelling blood out of their eyeballs to deter mainly canine predators. And this stream of blood can go for several times their own body length. So for this study, the main focus was 3 things. It was first to identify the environmental, human, and ecological factors that influence Texas horned lizard habitats, and then to use these factors to determine which areas are best suited for Texas horned lizard reintroduction. Currently, there are quite a few reintroduction projects going on, mainly done by organizations such as the Fort Worth and San Antonio Zoo, Texas Christian University, and Tinker Air Force Base. And then once these areas were determined, these results could be used to advise the reintroduction projects, as well as state and local agencies as to which areas would be best suited for Texas horned lizards. So the study area for this analysis was Texas and New Mexico. For a bit of context, the current reintroduction projects are mainly focused in South Texas, the lower Texas Panhandle, and the Texas Hill Country. And we can then compare that with the current Texas horned lizard range depicted here in purple. As you can see, it's mainly eastern Mexico and throughout much of western and south Texas. Now, after examining existing literature and some previous studies, it was found that the ideal habitat for Texas horned lizards is an area with arid climate, a mixture of bare ground, shrubs, and woody vegetation, since the lizards tend to use those areas for thermoregulation. It would also have sandy or loamy soil, since Texas horned lizards tend to bury away from predators, particularly swarm predators like fire ants. It would have an abundance of red harvester ants, since harvester ants comprise about 69% of the Texas horned lizard's daily diet. And ideally, no red imported fire ants. While the Texas horned lizard can eat these ants, they can't properly digest them due to chemicals in the ants. So here we can see a couple of the environmental factors. This isn't an all-encompassing list, just to get some context here. We have the majority land classification, the average rainfall in June, the average temperature in June, and the elevation across the entire study area. For some of the human factors, we have population density in the top left, road density, pipeline density in the bottom left, and that one will become particularly interesting later, and the percentage developed. For the ecological factors, we have the average tree canopy health, cattle density per square kilometer, percentage shrublands, and the various types of ants that inhabit each area, with a orange indicating that harvester ants are there, and the crosshatch indicating that fire ants are also present in that county. For the study methodology, the first step was to do a literature review and identify some potential factors that could influence where Texas horned lizards are suitably habitated. Then once these factors were identified, the data could be collected and then processed for analysis. And then once these input data sets were processed, they were then joined to county level shape files using their FIPS codes. And for an example of this, here we have on the left, we have a river network across New Mexico and Texas, and on the right is actually the average tree canopy health. And after processing the river network to get the average river density per square kilometer and taking the average value of the raster tree canopy health, we have the following maps, where the dark blue areas have higher river density and the darker green areas have higher tree canopy health density. Now, once all these factors were identified, forwards and backwards factor selection was done to identify which of these factors actually mattered for Texas horned lizard habitat suitability. And this was done to minimize the ACI-ICI information criteria and to keep the overall VIFs below 7.5 to prevent too much correlation going on there. And if a factor was identified in both forward and backward selection, it was considered to be a primary factor for this analysis. And once all these primary factors were identified, they were used to construct initial ordinary least squared regression models across the entire study area. And to examine these models, they were run through the following flow chart, which takes spatial autocorrelation diagnostics and determines if ordinary least squared is actually appropriate for that model, or if a different, more spatially oriented model would work better, such as spatial lag or spatial error models. So for New Mexico, this flowchart wasn't really a factor since the initial regression model was determined to be sufficient with the R-squared value, adjusted R-squared, the various p-values, Jark-Vera and Broich-Pagan test, as well as Moran's eye, LM errors, LM lags, robust LM errors, robust LM lags. But for Texas, on the other hand, it was determined that there was enough spatial autocorrelation that standard regression just wasn't going to cut it. So for Texas, the model is actually a spatial error model. Now, the reason that they require two different ones is most likely because each state is so unique in its various climates and habitats, where New Mexico tends to be relatively homogeneous across the entire state, where it's mainly all arid and some areas are more mountainous than others. But trying to compare West Texas near El Paso over to East Texas, where it's mainly swampland, it's hard to construct a model that would cover both. From there, after we constructed both these models, the model equations were used to determine a habitat suitability value. And then these habitat suitability values were used to determine how suitable each county was for Texas horned lizard reintroduction. So moving on to the initial findings, on the left here, we can see a list of the potential factors that were brought into the study. And then after everything was run, it was found that in Texas, the significant factors for Texas horned lizards were precipitation, land use category, prevalence of red harvester ants, and natural gas pipeline density. And for New Mexico, it was determined that land use category, again, harvester ant prevalence, elevation, road density, and again, natural gas pipeline density were the significant factors. And in both cases, natural gas pipeline density was found to be the most detrimental factor to Texas horned lizard habitat suitability, where it hurt the overall suitability score more than any other single factor. So using these factors in the aforementioned models, the habitat suitability scores were calculated, and these scores ranged from negative 0.287 to 1.312, where the lower end values at or below 0 indicate that that county is poorly suited for Texas horned lizards, and the values at or above 1 indicate that it is the most suitable counties. These values were then divided into 5 different groups using Jenks natural breaks to make 5 different categories: very poor, poor, average, good, and excellent. It is also worth noting that since 2 different models were used, the numbers of one state cannot be directly compared to the numbers of another, but they can be used to compare counties within the state. So you can compare apples to apples and oranges to oranges, or Texas to Texas, New Mexico to New Mexico, but not across the state lines. So using these values, this is the overall habitat suitability map across the study area, where, as the legend shows, the darker green areas are the better suited regions, and the orangish reddish ones are poorly or very poorly suited for Texas horned lizards. Now, I'd like to draw your attention to a couple areas of interest with this. The first being that the most suitable regions in Texas were found to be South Texas, the Lower Texas Panhandle, and the Edwards Plateau, which is west of the Hill Country. And the least suitable area in Texas was found to be Eastern Texas, between the Sabine and the Natchez rivers. Now, for New Mexico, the best regions were found to be Southern and Eastern New Mexico, with the most poorly suited being Northern New Mexico. Now, in particular, the best suited singular county in Texas was found to be Cameron County down by Harlingen and Brownsville. And the least suitable county was found to be Panola County over in East Texas. And for New Mexico, the best suited county was Quay County over by Tucumcari. And the least suitable county was Los Alamos County in northern New Mexico. Now, to answer some of the study objectives, the first being the factor identification. The study found that the best suited area for Texas horned lizard reintroduction would be an area with low precipitation, a high percentage of open water or snow land classification, a high prevalence of red harvester ants, low elevation, low road density, and very low natural gas pipeline density. And over to the right here, we can see an image of kind of what that environment would look like at a mountain near Tucumcari over in Quay County. For the second objective, these factors were used to identify the following regions as best suited for Texas horned lizards, that being South Texas, Texas Panhandle, the Edwards Plateau, and southern and eastern New Mexico. And all these regions can be seen at the bottom left in those golden boxes. On the right here, we see kind of an aerial view of what that environment would look like in the Edwards Plateau here. And for the final objective, with these results, I would advise conservation and reintroduction efforts to take the following steps. That being to shift their current efforts away from just the hill country, which was found to be either poorly or just adequately suited for Texas horned lizards, to include the Edwards Plateau here pictured on the right, which encompasses the regions in and around Del Rio. Since this area is much better suited, and it was found in some previous studies that reintroducing a population of horned lizards near an existing population, such as the one that has been being built in the hill country, increases the chance of survival for both parties. Beyond that, I would advise reintroduction efforts in Western Texas to consider using some areas in Eastern and Southern New Mexico, since most of the reintroduction efforts tend to be focused solely in the state of Texas and kind of rarely cross state lines, which unfortunately is neglecting a large swath of the region that could be used to build their native population. And beyond all that, I would advise, since both road density and natural gas pipeline density were found to really hurt how suitable a region was for Texas horned lizards, that in all the areas I previously mentioned, natural gas pipelines and road construction should be maybe not stopped, but definitely slowed to preserve these areas for future populations of Texas horned lizards. Now, with all those in mind, hopefully we'll be able to see continued success for these reintroduction efforts, and hopefully some more wins like the 600th successful Texas horned lizard hatching that actually happened in my hometown of Fort Worth, Texas. And hopefully the Texas horned lizard can continue to be a beloved staple in the American Southwest for many, many years to come. With that, that concludes my briefing, and I'll be happy to field some questions.